So good afternoon and welcome everyone to this webinar on insights from Denmark behind the meter gas production. This webinar is coming to you from the Trade Council of Denmark, A2EP, and the Race for 2030. My name is Jared Leake and I'm the CEO of the Australian Alliance for Energy Productivity, and I'd like to commence this webinar with an acknowledgement to the traditional custodians of country throughout Australia and their connections to land, sea and community, and pay our respects to their elders. And for me, I'm coming to you from in northern Sydney, which is Darramurrugal lands. And just quickly on A2EP, we are a member-funded organisation with a beautiful cross-section of members that support our vision to improve energy decarbonisation, energy productivity and decarbonisation across Australia. And we're so fortunate to have these supporting members and really help us with progressing decarbonisation in Australia. Just a little bit of housekeeping for you all. This presentation will be distributed along with the recording early next week. We definitely want to take your questions, so please get them ready for us. And if you can just enter that in the Q&A box down the bottom, that's great, and upvote other questions that you like, or feel free to have a chat on the sidebar, whatever works for you. I'm flying solo on the A2EP team today. I don't have anyone joining me, but we do have a stellar cast joining us here today. And so I'd first like to welcome Dorothy Dellosa, from the Senior Advisor from Trade Council of Denmark. Hello, Dorothy.
Hi, Jared. Thank you so much for this opportunity. Looking forward to the chat today.
Absolutely, and welcome to you. And as well, we have Tracy Colley, Program Leader for the Race for 2030 CRC. Hello, Tracy.
Afternoon.
Also joining us, we have a team dialing in from Ramble. This is where we're going to get the main insights from Denmark, and that is we have Reza Yosri, Manuel Ortiz, and Dr. Maria Puig Arnavat joining us as well. So welcome to Team Ramble, and we look forward to a presentation coming up shortly. Also joining us today is Liz Hutton. Works with DPI and for New South Wales and New South Wales Decarb Hub, and former employee for A2EP, and one hell of a project manager and project officer. Hello, Liz. Welcome.
Hello, Jared.
And then finally on our panel today, we have Professor Prasad Kaparaju. I'm going to go out on a limb and say the leading researcher we have in Australia for anaerobic digestion. Sorry to embarrass you like that, Prasad, but every time you talk, we learn. So, but welcome and great to have you here today, Prasad.
Hi, everyone. Thank you, Gerard.
So a little bit of scene setting, and we thought we'd start off with a little bit of the research component behind it and how race is going to be able to contribute to these findings that we have here today. And so, Tracy, I'll drive the slides, but if you like, just talk us through how race is working in this industry and how it's going to be able to feed into what we learn here today from Ramble.
Sounds great. Thanks, Jared. So this is just a quick summary overview of the work that RACE has done to date in biogas. And it's really about supporting the emerging biogas industry in Australia, a lot of which really is making up for lost time. So next slide. RACE for 2030. RACE stands for Reliable, Affordable, Clean Energy. We are a cooperative research centre and have close to $70 million in federal government funding. Started in 2020 and we go through to 2030. And our key metrics are about greenhouse savings, energy cost savings, and we're particularly focused on consumers, so not large-scale renewables generation. Next. So the biogas research to date has been embedded within the Race for Business program. We do have 5 different research programs, and biogas is embedded within the decarbonising business and supply chains research theme, which is in the Race for Business program, right up the top right there. Next. So to date, the main bit of work we've done is the opportunity assessment for anaerobic digestion and electricity transport and gas. which Prasad was intimately involved with. The outcomes of that project really found that when we looked at the potential for biogas generation in 2050, if we looked at today's numbers and it was producing at the optimum level, biogas could be producing 23% of the current fossil methane use. And by the time we get to 2050, when as many industries as possible have converted from gas to electrification wherever possible for their heating needs, it could provide over 50% of the heating required there. Substantial amount of jobs, 18,000 jobs, most of those in regional areas. It's substantial inputs to the economy, $50 billion in additional GDP. And also avoiding substantial greenhouse emissions every single year. Next. So the opportunity assessment identified a range of different projects. Some of them are highlighted there in terms of their potential benefit to the economy in terms of millions of dollars per year. We've identified some short-term priorities for the industry in terms of helping to make the economics of projects stronger. But a lot of these projects need, as always, support from industry in terms of cash contributions for us to be able to match with federal government funds. So the main front runners are digestate, assessment and standardization. Victoria's ahead on that one, but it'd be great if we took a cooperative, coordinated approach across the country that was risk-based, looking at what's happened overseas. Biomethane quality specifications, looking at using everything that comes out of a biomethane plant, so using bio-CO2, not just the biomethane, but also looking at how we value biomethane. So to date, in terms of a inclusive renewable energy market, we do have the green gas scheme, but unfortunately, most of the current regulatory regimes, guarantee of origin, various renewable fuel schemes, have focused mostly on hydrogen, not on biomethane. So lots of work still to do. In terms of outcomes from projects, we had one project, Prasad once again was the lead on this one, was looking at ag waste from the sugar sector. It found that large centralized plants were the best option, but once again, a bit of CapEx support was required. A project that was run out of UTS in Sydney with Sydney Water looked at quantifying the resource available from urban organics, diverting them from landfill and to anaerobic digestion, and that found there was significant potential in terms of biogas potential from that feedstock source in urban areas. And the final project was looking at optimizing the treatment of sewage sludge from wastewater treatment plants, and it found that you could actually increase the production of biomethane from wastewater treatment plants by using thermal hydrolysis, or wet oxidation. Thermal hydrolysis was the best in terms of economics, but once again, capital support required to be able to deliver that. We also have a current project underway, Energy Flexibility for Water Corporations, which is being run out of RMIT. It's really about optimizing energy cost and greenhouse outcomes for a site by coordinating what happens with electricity consumption, flexible demand, on-site EV charging, on-site solar PV, linking to surrounding resi PV, and potentially also community batteries. And it has a linked PhD project that's about maximising renewable energy for water corps. Next. There are also one PhD underway with UTS that is about optimal planning for biogas in wastewater treatment plants, and one that is still Prasad and team are working on identifying a student for sugar mills. Yep, we also have PhD projects as part of RACE, which are, if you're not in a hurry, they take 3 years. Very cost-effective way of getting some top-notch research for your organisation. We also have one upcoming project from QUT, which is looking at addressing ammonia inhibition in anaerobic digestion. And it's a proof of concept project, has been done overseas, but not yet in Australia. So we're looking at doing that. But basically, I mean, they're the current and completed projects, but in terms of any sort of projects we can support moving forward. To date, we've done a lot of techno-economic type analyses, but we can look at basically any issue which is slowing down decarbonisation at scale or at pace. So that could be customer preferences and business models, market pricing and regulatory design, knowledge sharing and market transformation, which can be about consumer acceptance, knowledge sharing with a range of different people in organizations who need to make decisions about biomethane projects, but also system planning capabilities and operations. So training requirements, basically anything that's going to help support the industry, we can look at supporting from a research perspective. So how do we work? We can basically provide nearly half of the research costs of a project between us and our research partners. We're looking at how, for existing feedstocks, we can increase the biogas production from that feedstock by looking at things like anaerobic co-digestion, removing inhibition. We also can look at how to incorporate flexible electricity demand into the project overall. Participating in FCAS markets, so that's about reducing cost, but also reducing greenhouse emissions. Also looking at taking a whole of site approach, so integrating PV, building integrated PV. Once again, the required outcome is reducing costs and greenhouse. And what we ideally like to see in project is a collaborative approach. So we have industry representatives, but also representatives from government who are involved in regulation and incentives for project as well. And what we hope the net result will be is that for the industry, we can help reduce the compliance costs of project, which leads to faster implementation and uptake of the technology and biomethane projects more widely. Thanks, Jared.
Brilliant. Thank you so much, Tracy. As we go through this presentation from Ramble, we see that, yes, there's some great things happening there, but there is so much more to do. And we'll certainly get some more comments from Professor Caporaju coming up to talk about some of those research and more that we can do as well. We are comparing Australia and Denmark today, so I thought we don't want to just pretend that we can just copy paste everything, and Denmark is the gold standard completely. We can just copy. So I thought I'll just be clear. We know that there are differences there. We are a much larger, more dispersed country without the density of farming and what have you, and we do have much higher gas usage. We do both have very large dairy industries, and that's certainly where a lot of the opportunity has come from in Denmark, and that'll be explored today. But of course, in Denmark, they're more likely to do a shedding operation where cows will live inside a shed for a large portion of the year, where that does not really happen in Australia, barring a couple of very large farms. So there absolutely is differences. The other one also on the Denmark is a net importer of nutrients through a lot of soy imports, and that does create some unique water issues. That means that they're more likely to put certain regulations in place to help with encourage the manure usage and what have you. And so absolutely appreciate that there's not a perfect one-for-one copy paste here, but there's a hell of a lot we can learn. And with that, then I'm going to hand over to Dorothy for introduction, a little bit more on the Trade Council and introduction for Ramble. Dorothy, over to you. Just on mute there, Dorothy. Okay. We've got your slides up. You just need to unmute.
All good. So
Gotcha.
thank you, everyone. And again, thank you for the great introduction, Jared and Tracy, about the program. So again, I'm Dorothy Dellosa, the Senior Advisor from the Trade Council of Denmark. So just to give you a little bit of introduction, the Trade Council is spread across 105 offices in 79 countries, and we are part of the Ministry of Foreign Affairs of Denmark. We are a nonprofit organization, and our commitment is really to share knowledge, which is why we are partnering with our collaboration partners, Race 2030 and A2EP, sharing best practices, innovation, and sustainable green solutions between nations and companies. And lastly, we're also your bridge to Denmark to Australia, helping Danish companies also on their export and foreign investment here in Australia and New Zealand. So I know we are pressed with time, and we just really wanted to highlight the experts from Ramble today. But the main question that we receive is that why Denmark is here in Australia. So Denmark is a small country with really big ambitions to have a 70% reduction and achieving reduction of greenhouse gas emission by 2030. And neutral, being climate neutral in 2050, they really need to have great partners and spread across different countries to make an inspiration and also apply these technologies and also these learnings. So again, it's a transition into that green journey from black to green, where it all started back in 1973. 1973 was an oil crisis, and that really struck a nerve and made Denmark realize that they don't want to be a oil-dependent country. So 90% of their energy were based on imported oil. So that came about, that inspiration and aspiration to really turn that energy dependency into that green transition. And now we are sharing with you what are these key learnings on making a sustainable, low carbon, and resource efficient society. So just a recap or just an overview of the biogas production. Currently, there are 150 biogas plants in Denmark. Mostly 75% are livestock waste and 25% are from different organic waste like household, straw, and energy crops. And also, it used to be only electricity production, but right now they're currently 80% is upgraded and fed into the natural gas grid. So that is really something that why Jared and Tracy and I really wanted to bring this session come into play. What can we learn about and how can we adopt some of these key learnings? And then in 2023, almost 40% of biomethane is into the Danish gas system. And then they're also very ambitious to the goal by 2030. They wanted 100% green gas consumption. And on your right is just really a graph showing when the subsidy scheme came arise, there is a portion of usage of electricity, process heat, and also biomethane. So I know Ramble will be talking more about this one, and I want that opportunity for them to really discuss about this one. And the main really inspiration is really they're also improving their process as we go along. And currently, they also are trying to improve the methane loss from biogas plants, making sure they use sustainable materials like use of straw, 100% green gas by 2030. They're also trying to phase out the use of energy crops like corn, because of course it's also a food competition and it promotes waste use. Then also utilizing more of the manure and organic waste. So the inspiration came about that there had been a lot of talks about biogas, and we saw the gap in opportunity to invite experts from Denmark. And who else is there but Ramble, who has been in the business for more than 30 years, doing a lot of bioenergy and biogas projects, and currently on their path of turning 100% efficiency with bioenergy with 350 plus projects across the globe. So I think not to further delay the discussion, and again, for everybody's informative session, I will now introduce you to the Ramble team. Good morning and also good afternoon from Melbourne and also from Denmark. Thank you.
Thank you so much, Dorothy. Hello, everyone. My name is Reza. I'm joining from Ramble Australia. Today is with me Manuel Ortiz and Maria as well from the Denmark Copenhagen office. So I'll start sharing my screen to go through the presentation and to discuss. Hopefully everyone can see my screen now. Okay, good. So the title of the presentation today that we're going to discuss is biogas development in Denmark, as mentioned, and what is the insight and opportunities that we can learn in Australia in here. So first of all, I start acknowledging the country. Ramble acknowledge the traditional owners of the land we are meeting on today. I'm from the Wurundjeri people and the traditional owners throughout Australia, where Ramble carry out the work and projects, and we pay our respects to their elders past and present. So just a bit of the Ramble. Ramble, as mentioned, is a Danish company. It started in 1945, and it has been belong to Ramble Foundation. And we operate in 35 countries with more than 18,000 people, and our revenue for the last financial year was 2.3 billion. And we are, importantly, independent architecture, engineering, and consultancy company. So we are consultants, and this is the main business that we do across different countries in the world. So just in Australia, we have 4 main offices in Perth, Melbourne, which I'm from, Sydney, and Newcastle. And the business units that we have in Australia are energy, environmental and health, architecture and landscape with the brand called Hunting Larsen, and then water and transport. So the first thing that we're gonna go, probably some of you know about what is biogas, but for me is trying to just give you and setting the scene, okay, what is the biogas and why this is important. So biogas is, as you can see in the middle of the anaerobic digestion happening, is what we have, the biogas generated. So in the absence of the oxygen, what we have as a feedstock, which could be anything from the agricultural waste to manure or organic portion of the municipal solid waste, we can feed into the anaerobic digestion system. And with the absence of the oxygen, the bacteria is going to decompose the organic materials and create biogas, which is biogas is mainly methane and CO2. So again, methane is what we equivalent what we usually have in natural gas. Is more than, again, 60% of that usually is going to be methane, and then the rest is going to be CO2 and other impurities. So one thing that is important, what we can do, we can actually use upgrading technologies that are out there to create the biogas, and then we can either use actually in the electricity generation using cogeneration or CHP to create electricity and sell back to the grid, or we can upgrade it using different technologies to create, again, 2 added value components, which is the biomethane. Then you can actually use it and inject it back to the grid, and also carbon dioxide. And one thing that actually is quite interesting happening worldwide is that this green carbon dioxide is becoming like a commodity for a lot of application, from food processing technologies until for power to X applications as well, where you can create e-fuels. Also, digestate out of it, it's quite important that you can use and either through the separation and water treatment, and again use it as a fertilizer in the suppliers when we create the feedstock for the anaerobic digestion, which is quite a circular economy as well. And again, you can do different things as well. Pre-treatment is going to be important. But then the 3 objectives that leading a strong growth of the biogas in the European Union and as well as the Denmark is the 3 main things that we see in here. So first of all, because of definitely decarbonisation, we are avoiding the methane emissions generated by the waste. So again, Another important part is that if we use the digestate from our anaerobic digestion system, there's a prevention of the need for the synthetic fertilizer. And again, there's a potential for replacing fossil fuels with bio-based fuels as well. Also, as I mentioned, CO2 can be used from the anaerobic digestion system as a biogenic or green CO2 for creating power-to-X applications and fuels and synthetic fuels. Also, it's a circular economy. It's more sustainable agriculture practices. And again, using and capturing this separated biogenic CO2 is improve the circular economy. Also, in Europe, energy security is quite important. In Australia as well, it's becoming important because of the, as you know, the Bass Strait and everything that we might need more gas into the gas network system. In Europe, the Russian invasion to the Ukraine resulted in the energy crisis. And one of the things that EU put the energy policy needs to face is structural changes in supply sources. And what they did is trying to increase the biogas uptake by 35 BCM in 2030, which is an important number and very big number there. So over to you, Maria, which you're going to discuss about biogas development in Denmark.
Yes, thank you, Reza. So in the next 4 slides, I want to provide an overview of the current status of the biogas sector in Denmark, and also show you how it's different from other European countries that they also have a mature biogas sector. So in here you have a map that shows the existing biogas plants from 2023, the main ones, and then the production of biomethane to the gas system. So the Denmark's gas infrastructure plays an important role for the regional natural gas security, as it connects the Dutch, German, Polish, and Swedish gas systems to the wider European systems with the Norwegian gas resources. So as you can see here, we have the Danish gas system that consists of production facilities, around 190 plants. And what makes this case particularly interesting is that the Danish biogas plants are predominantly large-scale industrial plants, so that they can take up to 1 million of tons per year of Fitstock, when in other countries with also mature biogas markets such as Italy, Germany, and France, we see these plants being much smaller, like 4 times smaller. So that's what makes a big difference here in the biogas sector in Denmark, that we have these large-scale plants. And we have the largest scale plants, I mean, in whole Europe and in the world. So then, in addition to these plants, we have the transmission line, the transmission grid, that is the one you see in the thicker yellow line. This line is owned by Energinet, and then we have the distribution gas grid that is owned by Evida. In addition to this, there's the pipelines that connect with Sweden, that connect with Germany, and we have the Baltic pipeline that carries the gas from Norway through Denmark to Poland and neighboring countries. And it started in operation in 2022. And in Denmark, as you can see in the southern part of Zealand, there's a connection to these 2 islands in the south of Denmark, because these 2 islands, now there is no gas infrastructure, and they want to develop biogas plants in there. So that's why they are building this pipeline that will be in operation end of this year. So some aspects that were mentioned before, but it's important to keep in mind that are very relevant in the Danish biogas sector, is that the 1/3 of the total manure produced in the country is used in the biogas plant. And this manure makes up for 75% of the raw feedstock mix. Then there's a maximum input share of energy crops that is set at 4%, and they want to reduce it further. Then there's new regulation on methane leaks to achieve methane leaks of maximum 1%. That's the goal, with inspections annually. And then the current biogas and biomethane subsidy frameworks that have been existing until now are being replaced by a new system for only biomethane and e-methane in the form of tenders. And what has also helped Denmark to have this well-developed and mature biogas sector and these huge plants is that they have a simple digestate management system where the farmers deliver the manure to the biogas plants, and then they take the digestate back and they use it as a fertilizer in their fields. We have seen other countries like Italy, Spain, Netherlands, where the digestate management system is much more complex and it's very difficult to get rid of the digestate. And it's also expensive. So next slide. So if we look at the biomethane's contribution to the Danish gas grid, we can see that it went from around 10% in January 2020 up to the peak that was reached in the second half of 2023 of 39.7. The governmental ambition, initially it was set to achieve 100% of green gas by 2034 in the green gas strategy, but now this has been moved and the goal is to achieve it in 2030. How this will be achieved is a combination of two factors. One, it's expected that the gas consumption, as shown in the picture here above in the pie figures, that the gas consumption will be reduced. And then on the other side is that the biomethane, it will be reduced mainly because of electrification and different measures, applied to increase energy efficiency and reduce energy consumption. And then on top of that, there will be an increase on the biomethane production because there will be new plants built. And this will make it possible to achieve 100% green gas in the natural gas grid. Next, yeah, here I wanted to give you compare a bit the Danish biogas sector to other European countries, just by giving some numbers. So you see from left to right, on the left side we have this figure that shows the high share of biogas plants with upgrading technology. That means biogas plants that separate the CO2 from the methane, and then their objective is produce biomethane and not only biogas, because the biogas production, it has remained constant since 2013, but the biomethane production has increased exponentially. So compared with other countries where they still have a lot of biogas plants, here we focus on biomethane production. Then, as mentioned before by Dorothy, there's a high share of biomethane plants connected to the gas grid. You can see here that most of the plants inject in the distribution grid, and very few in the transport grid, and that poses a challenge to the operators of the grid, EnergyNet and Evide, to maintain the system balance as the supply of the biomethane in the local distribution grids exceeds the gas demand. And that's especially important during summer when there's a lower consumption of gas. So to maintain the system balance, EnergyNet owns and operates 4 reverse flow facilities and is building more. So these facilities, what they do is they compress the biomethane from the 40 bars of the distribution grid to 80 bars of the transmission grid. And that's something that in Denmark is very clear, and it's known that is EnergyNet who owns and operates them, but in other countries that is not established yet, so it can create some barriers when trying to inject to the grid. And the last figure on the right, it shows that these plants in Denmark, if we look at the average biomethane plant size per country, we can see that in Denmark has the biggest plants in Europe. And as mentioned before, it's important to highlight that there's a high share of manure in the feedstock mix. What we use here is mainly domestic feedstock. So this manure comes from 25 kilometers from where the plant is located. And now we're seeing an interest and increase on the straw on the feedstock input, because this is crucial for the future green gas target. But we see that if we compare Denmark with other countries like Germany, they still use a lot of energy crops in their plants. the figures on the right, they show example from 2021 and 2022 on the feedstock input and how these inputs translate into the biogas production. So we can see that even if we have a big share of manure slurry as a feedstock input, it's 66%, then it only translates to 20% of biogas production. While with other feedstocks like industrial waste, then the production of biogas is higher because they are more energy intense feedstocks.
So yeah, I'll jump back again on this. What we are trying to say in here, how Denmark reached to the point that they reached today. And this is like a histogram showing what has been done so far there and what literally for Australia, how we can learn from this. So just again, similar to what we had in Australia as well from early 1920s, when the covered lagoon was the case, wastewater treatment plants was producing biogas and generating using CHPs electricity or cogeneration creating electricity. And then this is what happened in 1975 after oil crisis, as mentioned by Maria. The first manure-based biogas plant is constructed in Denmark, which is happened to create biogas for their local use as well. What has happened in one of the things that from early 80s, from late 80s to early 2000, what happened that the farmers association gathered together and a couple of farmers with the enough feedstock start operating jointly owned biogas plants that constructed, and that was again 10 to 20 local farmers using CHPs and also for their heat and power generation. That was the case, and it was mainly behind the meter. And in 2009, the political decisions come to effect, and they were objective of using at least 50% of the manure from Danish livestock to convert it to the energy. And one of the things that get the uptakes of the biogas injection back to the grid as started from 2012 when the energy agreement introduced a feed-in subsidy for injecting biogas into the gas grid, which we don't have in Australia, for example. So what happened in there is then it started the momentum in the industry to fill the gap between the biogas production and as well as the cost associated with it compared to the natural gas to make sure that with the right amount of the subsidies, the projects are going to make financially viable. It started from 2014 from 0% to something reaching to 2018. It's again started more than 19 manure-based biogas plants in operation with roughly around 10% injection back to the grid. And that was the time that the industry and momentum is starting picking up. And that was the time for closure of some of the subsidy schemes that they had in place. And what happened in 2023, 39.7%, almost 40% of the national gas grid network was biometering, as I mentioned. And now it's complete closure of the biogas. Now there is the introduction of the biogas tenders that it's trying to keep up the momentum in there without directly subsidizing the plant. Right now, it's actually around 190 biogas plants in Denmark operating up to 2024, which is quite important. So if we decide how Denmark reached this point, and based on the energy net, they've done it in 5 steps that we want to know how we can reach to that in these baby steps to reach to the 5 continental when you have everything actually covered in the biogas market. So step 1 and 2, which is more interested for Australian context, is that, okay, how we can subsidize it, biogas generation, and as well as upgrading back to the grid and inclusion of the biomethane in the national gas grid network. These are the important parts that we want to take actions in Australia in order to get the industry work. What is happening at the moment Denmark is in step 4, which it's in the connected cross-border flows for the biomethane and all these fantastic things that mentioned by my colleague Maria beforehand. It's happening in here. In Australia, we are almost finishing with step 1, except that there's no subsidy scheme as of yet. But definitely what we're going to need is taking some more actions to get to the step 2 as well, to keep the momentum going. To go a bit on the detail, how these early enablers help Denmark, my colleague Manuel is going to take the lead again.
Yes, thank you, Reza. So there are some key enablers for the Danish early success, and they are wrapped around 5 main topics that I'm going to discuss briefly. First is the infrastructure, as Maria said, that there's a pipeline connecting and upgrading, when enabling the upgrading plant into the distribution network. And it's a bit dense in Denmark and is being developed. So that's probably a difference with Australia. In addition, the infrastructure has revised the standards and making it possible to inject biogas. You have some stringent requirements coming from the old fossil fuel era. Then it's large to integrate at scale and at low cost biogas. Second point is the market. Of course, you need to create a set of conditions to be able to sell and buy the biogas in the natural gas market model. And one of the benefits in Denmark was also the opportunities to sell to other European countries. In addition, there was some sharing of the added value of biogas to the farmers, not always monetary, but also waste disposal for the farmers and getting the digestate back. So depending on the setup, there are different ways of sharing the income or sharing or providing some benefits for them. In terms of value, there are different setups possible, from guarantees of origin schemes to sustainability schemes and targets or these premiums. So there are ways that to value the benefit provided by biomethane into the gas grid. Next, Reza. Yes. Sorry. And then fourth, in terms of the regulation, there are a lot of regulations that have been put in place, and this regulation has evolved with the market. But probably one of the ones we have to list is the right to inject policy. All plants can connect to the gas grid, and it's responsibility of the gas grid to make a line available to the developer. The permitting approvals have got easier to secure, and the digestate management plan, it's also simplified. There are targets to use waste as a feedstock, and there's European targets also to reach some level of shares of biofuels in the transport sector. And finally, but not least, the subsidy. Initially, there were some subsidies for users. The subsidy has evolved with time, and now it's being phased out, and a new subsidy is coming to life that we can talk a bit later on the Q&As. But the key solution, or the key conclusion here, the key message, is that there's a need to create stability in the biogas sector with long-term policy and targets to attract the investment. Probably in Australia, also common strategies on the different regions will help, rather than having too many different policies. And the latest one also on how Denmark differentiates from others is that, as Maria said, there are other European countries that have quite an advanced biogas industry. What is interesting about Denmark is that they have managed to develop a quite substantial biomethane production while keeping low the operational support. So they have been very efficient at using the money and putting the incentives to work to make possible these 100% supply by 2030. And maybe I saw we can go to to the next, Reza, and to the following one. Here we have some examples that we wanted to showcase, and maybe we can also use them to answer some of the questions already. This is one of the big players in Danish biogas. It's Natural Energy, who was acquired by Shell last year. They have 14 plants. They are treating 4.7 million tons of biomass. They have plants with use of biogenic CO2 that they are giving it to food grade, or bringing it to food grade quality and using in the food industry. There's also biomethanation. So when the biogas is split into biomethane, it's injected into the grid, and the CO2, that CO2, it's combined in another bioreactor with hydrogen to produce more methane. And maybe the next, Reza. Yes, in this plant, which is one of the largest in Europe, in Tonne, 900,000 tons per year, 40 million normal cubic meters of methane, and around 400 gigawatt hours per year. This plant also has CO2 utilization that is used for a power-to-X application. So it's combined by hydrogen in another facility, and they produce methanol. And maybe the last. So the other two plants were in operation, but also to say that there's development and there's new things and new technologies that are brought by the market. And this is one of the examples. That is a plant that will focus only on straw as a mono feedstock. So it's a different setup, not co-digestion, but looking at straw, producing 150 million normal cubic meters of methane, and also looking at integrating with hydrogen and then to produce methanol at the end.
Yeah, I'll take the conclusion as well. So what we are trying to do in Ramble Australia, with using our Danish experts like Manuel and Maria as well, try to help Australia in this sector. And the key conclusion for what we are saying is incentives and mandates are key for developing the bioenergy projects. And also, because what you've learned so far, Australia is well positioned to take these advantages and emergence of these bio-to-X technologies. So anaerobic digestion can be scaled up definitely, and could be a source of green gas, green carbon, and biofertilizer. That's a very important thing to notice. And Ramble, as a Danish company, we are here to get the insight from the Danish experience and the global experience that the Ramble have, and we are here to collaborate. That's all from our side. I'll stop sharing. And then,
yeah, well, thank you, Team Ramble, and thank you for answering questions. I'm not sure if was Manuel answering questions and presenting there at some stage. I'm not sure, but there's been plenty of answering our questions, and that's going well, and absolutely keep going with that as well. Yeah, wow, that was excellent. And so it feels like, hey, we see that in Australia we've got the foundations here. We know biogas within municipal, but we really are 10 years behind, and we've got a lot of work to do. Tracy, any reflections on that material just now?
Yeah, I guess the thing I love about Denmark is that they make a goal, and then they work out, once they've made the goal, they work out how they're going to get to it. And you can see that with their commitment to 50% of methane being used in AD. They made that commitment a long time ago because they said that's what we need to do. And then they try and implement policies and strategies and support to get to that target. Whereas Australia does it the other way around. We work out what can we actually do. And so we end up with targets that are probably not ambitious in terms of the government working out how it can support the industry. So I think that's one really fundamental difference. And also just that they've had decades of support for industry is really the main takeaway. So we're way behind.
Just going to take a question there we got come through from Mark, and then I'll throw to Liz on some comments. Was it about that manure collection there? That's mainly from closed sheds, as I understand, in Denmark, and we don't really have that luxury. However, I know we can absolutely collect a manure, but it's in Australia, certainly during the milking, and it's a percentage of the total manure, maybe not as much as in Denmark. Is that right? Is it's a case of it's not so much applicable, this manure collection for Australia? Or maybe to you, Reza, on that one.
Yeah. So again, the only thing that's let's not clear. So we in different studies shown that Australia has a lot of potentials in terms of the feedstock for the anaerobic digestion. Manure is not the only one, even though the manure it's a big portion of the Danish feedstock. But in Australia, we have different feedstock, for example, dairy effluents and all the things that can be used and utilized in the biogas anaerobic digestion system. And definitely we have the enough feedstock. And the key in here is going to be the co-digestion. So again, in Danish experience, the co-digestion worked and the technology is working there, but you need to know what exact percentage and stuff like that you need to mix in order to everything works. But in that case, yes, definitely, even though in Australia, manure not might be the best actually feedstock because of these, is we don't have actually collection of
plenty of
manure.
other feedstocks.
Exactly.
Yeah. And I can almost hear Scott Grierson from Mornington Peninsula already talking about wheat stubble and wheat chaff already. So plenty of other feedstocks there. Liz, you've worked with a lot of feasibility studies, and usually behind the meter, and usually sort of small scale, and looking to turn biogas into electricity. Just any reflections on that presentation now, and the results from that, those many feasibility studies, and the barriers and things that they faced. Any reflections?
Yeah, it was very interesting to see that transition in Denmark, because it's very much the work we've done in Department of Primary Industries has been focused on those small scale on-farm type biogas projects that are for self-consumption rather than injecting into the grid. Most of the biogas, agricultural biogas projects that I'm aware that have been successful have been at piggeries, because you've got that continuous, easily collected supply of high methane producing feedstock. And if you've got enough pigs, you've got that scale to make that high upfront capital cost of the system economically viable. We did do some feasibility studies in other industries a few years ago, and unfortunately none of those projects got off the ground, but they were very interesting learning in looking at what those kinds of barriers were to getting them off the ground, to maybe thinking about what could be done differently to under a different sort of setup might be. So a lot of the barriers were around the feedstock. So like the cost and the practicality of collecting a viable quantity of feedstock, and some of them, they didn't have this continuous flow. If it was a batch process, say, where that we had the poultry farms that had like batch processes, so you didn't have a nice continuous flow, and then you also had issues with the methane production potential of the feedstock. So that whole idea around the co-mingling, nice recipe, so you get that optimal sort of production. We didn't have that with these feasibility studies. And then there was also the issue of competing uses for feedstock, for sometimes they had an alternative use that might be higher value. That capex cost was really, because these were small scale, that upfront capex was just such a killer. As well, very hard to make the economics stack up when you have that high upfront capex cost and then the long payback period. And then with the yes, they were mostly looking to produce electricity, but there was one project that was looking to use the gas directly for heating purposes. It had a shorter, if they use the gas for heating, that project, it had a shorter payback period, and part of that was because they didn't have those sort of extra costs of the generator and the inefficiencies that come with that conversion as well. So just using it,
Well, if I'm hearing you
replacing.
there, this is back to this co-digestion as they've been able to achieve in Denmark, and that's what we need to, whatever underpins, whatever research is needed to underpin and encourage that that's there. If I'm not mistaken, Liz, a lot of those were just covered anaerobic lagoons, and
They were all
before
covered, yeah.
and before Professor Kaparaju teams in and says no more cows in Australia because they don't produce much when we need it the most, which is winter. Reza, a quick question, or for the team in Denmark. Most of your plants in Denmark are anaerobic digested, the actual reactor type, rather than covered anaerobic lagoons. Is that right?
Yes, that's right. I mean, in Denmark, there's no covered lagoons biogas plant.
And to expand a bit on the technology, it's CSTRs, continuous stir tanks, thermophilic and wet. So it's a fluid. So it's that creates also a high yield. And we have seen also a recent trend that typically when you go for continuous stir tanks and thermophilic, you can reduce the retention time. But we have seen the trend in the Danish industry now that you also extend the retention time. So you get all the yield possible out of the Fitstock. And we have seen the major players are doing that here.
So Prasad, before I start tearing my hair out, then why in Australia do we go for the opposite of that? We're either doing covered anaerobic lagoon, or we're looking for dry AD, not wet. What's the differences here? What's going on?
I think the best and easy answer is the costs, right? The capex, and I think in Australia we are looking for the low capex, and CALs are basically a fraction of what a full scale CSTR biogas plant from Europe technology looks like. So this came from, I think, in my opinion, from American side of this CAL thing. So because they just use the open ground ponds and then started to cover them and line up with the sheets, and then try to develop this gas collection systems and use the gas for on-site. So, but if you want to operate a biogas plant in a proper process performance and get high biogas yields, and I would say for materials like this manures and other industrial waste, we should go for a completely stirred tank reactors. And for wastewater, we use the USB reactors.
Absolutely. And while you're there, Prasad, this co-digestion, how do we, what's the research that we need in place to help with the EPAs and things to faster and quicker and more confident sort of approvals for when people want to do a co-digestion plant? What do we need to do here?
Yeah, I think it's the main issue in Australia is that I'm coming from Finland and Denmark, if you think of my technical research, because I have been I did my PhD in Finland and lived there for 12 years, and then I moved to Denmark and worked and lived there for 5 years. So I was working at DTU, and in 2003 to 2008, when I was in Denmark, co-digestion was a new mantra. So I had all my research was basically on that. And for us, it's the manure is the base substrate. And then we have a thumb rule that 80% should be manure and 20% should be organic waste from any industries. And I have worked at 2 biogas plants in Denmark, Snetsinge and Lintrup. I think our Danish speakers know those plants. And then Snetsinge biogas plant actually imported fish waste from Norway. So you can imagine how demand we have for core substrates if they have very high methane potential. And I sat one day at the Torso biogas plant and tried to see how much feedstock actually comes in, because everything that comes in from the industry is gate fee. And that gate fee is one of the main source of revenue for biogas plants. And in Australian context, we are so scared of using co-substrates because of the digested quality that comes out, and the lack of understanding of how we can actually regulate that pathogen control. So I have done quite much research on that, and we have shown that just doing temperature control during the process of a thermophilic biogas plant or a post-treatment of the digestate for a mesophilic biogas plant, a kind of a pasteurization or a sterilization process can actually contain all your pathogens. You can get all the regulatory requirements of the 3 indicator pathogens that we talk about: Clostridium, E. coli, or Enterococcus.
Thank you, Prasad. You hit the word right there, scared. Right now, our regulators are scared, and so we need, yeah, if you could just multiply your team by 10, come on, and we've got to get some funding going for this stuff as well. We've got to take this fear out of it and more decisions. Tracy, I know you've been monitoring the questions there, and there's a lot coming through. Any highlights or themes that seem to be coming through there on the questions?
I think one of the key things about the Danish setup versus here was the right to access the network. And I think Manuel has just replied to a question about who pays for that. But I guess that's another potential financial barrier is, if there's upgrades required, who pays. And it looks as though in Denmark it was paid through government grants or fixed connection costs. So that is, a potentially very big stumbling block for projects exporting. But I think maybe, Jared, if we can just include all the answers to the questions in the material we sent out. Thank you very much to the Ramble team for your fantastic responses to everyone. There's 4 still remaining. One to do with the current value of biomethane in Europe.
Yep.
But yeah, definitely, we could probably have had another hour of questions and answers.
It looks like it. And absolutely, we'll dump all of these questions and answers into the slide deck, and you'll get that for anyone that's registered, and we'll send that out to you as well. 1 more hour would have been appropriate. We're over time, so we'll have to close it there, and just got a few little finishing announcements and things there. If you just bear with me while I bring my presentation up. Dorothy, you've got a nice little tour that you're opening up for invitations here. Something happening in November there.
Yes, thank you. And again, thank you, Team Ramble. You have really, shared a lot of insights for us, and appreciate your time as well this morning, Manuel and Maria. Again, we are encouraging open for expression of interest. In November, there is a huge agriculture conference, and we wanted to tie that in to a biogas, bioenergy, and waste to energy study tour. It's a self-funded tour, but definitely we're open for invitation or anyone who would like to participate. Definitely collaborating with A2AP and Race 2030, all of the network. We're happy to bring you down and experience the real biogas operations in Denmark.
Brilliant. Thanks, Dorothy. If I hadn't been to Copenhagen already this year, I'd be back for sure. Brilliant.
Thank you.
And just a few other announcements there. So A2EP, and this, our main interest in biogas and biomethane, is to use it for renewable heat. And so we've got a conference coming up at the end of September. And biogas is one of the 3 main technologies that we'll be reviewing in sessions there. So that is open for registration. If you go to the conference website, renewableheatconference.com.au, all welcome there. Other little bits and pieces coming up from A2EP. We've got a freight webinar coming up. You'll be amazed at what's happening in terms of electric trucks and what have you. Going to get a great update there. We're going to take a look at batteries with their plummeting price. They're starting to come into the mix and be much more serious player. And we're going to let you know about the best ways of utilising such technology. We've got a member meeting coming up in Melbourne in the 20th of August, and we've got another one of our heat pump site tours coming up as well in the 7th of August. That's not far away at Brimbank Aquatic Centre, and another one at a place called PCAC, and then in the city of CBD, Melbourne as well. So all that's left then to say, Ramble, and to that lovely panel that joined me here today, thank you so much for this fascinating discussion. We could have gone for another hour. Thank you for trying to keep us on time as much as we did. We'll get these slides out to everybody there and share that fabulous insights that's going to help this industry a lot in Australia. So thank you so much for joining us, and hope you have a great afternoon, and look forward to seeing you at our next event. Thank you. Goodbye.